obtain the state space representation of armature controlled DC motor and field controlled DC motor. So this is the armature controlled DC motor. Here we can write expression for back EMF equal to EB equal to KB d theta by dt, where theta is the displacement and theta dot is the velocity of this rotor. This is first equation. Second equation is electrical equation. We can write E of t equal to the applied voltage. E of t equal to L dia by dt. Since the current through this is Ia, armature current, plus RIA, which opposes the back EMF, opposes the applied voltage. That's why that is also EB of t equal to applied voltage. What are all opposing? The drop in inductance, drop in resistance, and back EMF are opposing the applied voltage. This is second equation. Third equation is mechanical equation. J d square theta by dt square plus B d theta by dt equal to T M. This is third equation, mechanical equation. The relation between the electrical and the mechanical equation is the mechanical torque equal to KT IA. These are the four equations for armature controlled DC motor. We have to put them in state space model. Let us assume that theta displacement is one state variable x1. Therefore, theta dot equal to x1 dot equal to x2. x1 dot equal to x2 is one state equation. Then theta dot is x2, x1, x2. One more state variable is, let us take IA. IA as third variable, x3. Now, let us substitute all these in these equations and we'll find the final equation. EB equal to KB into d theta by dt is x2. That is x1 dot, that is equal to KB x2. E of t equal to L dia. IA is x3. IA is x3. Therefore, L dia by dt is x3 dot plus R x3 plus EB. EB can be written as KB x2. Therefore, x3 dot equal to E of t divided by L minus R by L x3 minus KB by L x2. This is first equation. X3 dot we got. Already x1 dot equal to x2 is first equation. Let us assume this as second equation. We have to find x2 dot. x2 dot can be obtained from this equation. What is that? 3 implies this is from what? This is 1 implies. This is 2 implies. 3 implies that J x second derivative x2 dot plus B x2 equal to Tm. Tm equal to KT IA. IA is x3. Or we can write x2 dot equal to KT by J x3 minus B by J x2. So we got three equations, three first order equations. We have to put them in state space. That's all. If you put them in state space, we'll get the final model. So A is x1 dot, x1 dot, x2 dot, and x3 dot equal to 3 by 3 matrix, because there are three state variables, x1, x2, and x3, plus B matrix multiplied by E of t. E of t is the input. So x1 dot equal to x2 is the A equation. Therefore, 0, 1, 0. x2 dot equal to x2 dot is 0 minus B by J and KT by J. x3 dot equal to what? This is this x3 dot equal to, that is also, there is no x1, that's why 0. And x2 is minus KB by L, minus KB by L, and minus R by L, minus R by L. The E of t is in the third equation only, no E of t in first equation, no E of t in the second equation, E of t in the third equation, that is 1 by L. That's all. This is the state space model of armature controlled DC motor.